Welcome to the React Show once again. I'm really excited today. I know I say I'm excited a lot, but I am really excited for this episode. This is something I've been passionate about for a really long time, basically since I've been programming. And that is, how do you become a better programmer? And not necessarily in the cog in a machine type better programmer that a lot of corporations generally are looking for. This is how do you actually write better programs and be better at programming in general? And I want to be very clear, this isn't career advice. It may not help you at your current position. There might be corporations and other companies that are looking for this kind of thing, but what we're really talking about is not always something that they're looking for, and that is being good at the act of programming itself, not just one specific language or something. So now that I've made this sound less exciting, I actually am really excited. I think it's something everyone should want to do, so we'll get into that. So again, we're with Owl Creek, a high-performance React consultancy. And I am your host, Thomas, with my co-host, Austin here. Welcome to the show, Austin.
Howdy.
So it's always great to have you, Austin. We wouldn't be the same without you.
I'm looking forward to today's episode because I'm not very good at programming. So this should help me get a little better, or at least get some ideas.
I don't think I would agree with you on that one.
Well, thank you.
But like always, welcome to the show, Austin. And if you have feedback or questions, send them to the React Show at owlcreek.studio. And if you haven't done this already, please don't forget to subscribe, rate, and comment on this podcast. It really does help us continue to bring shows like this to you every week. So if you like this, if you enjoy this, please take a second to do that. We'd really appreciate it.
You're our inspiration to keep going. So please reach out.
Yeah, absolutely. Enough with the intro. I think it's a good time to get into the show. So today we're going to be talking about how you get better as a programmer. And I feel like when I hear other people talk about this or read about it from them, something that helps me a lot is to know sort of their background, where they're coming from, so that I can better evaluate the sort of advice that I'm getting. And so I'll just give you a quick rundown of my background. We have previously heard some of Austin's, but Austin, at the end of this, you're welcome to tell us more if you feel there's relevant information.
No, I'm more interested in learning how you got started.
Yeah, we might have to save story time for another episode, because this one I think is already going to run long. But we will get to it. Don't worry, you'll get it.
Promise?
Yeah, I promise.
Okay, good.
Pinky swear. Yeah. A little bit of a quick history of my background. I started programming over 20 years ago with HTML. And shortly after that, Borland C++ that I got from a friend back before I had access to a free C++ compiler. I don't know
That's
how.
a pretty big jump. HTML to C++.
Nice. It was the only person I knew that knew anything about programming other than... So my cousin introduced me to HTML, but he only knew HTML. And so I had this one friend that I went to school with that knew something about programming and didn't actually know much, but had these books on Borland C++. So that's, so I did a little bit of that. I didn't understand basically any of it, but I made some stuff happen. Anyways, that's sort of how I got started, and I won't go in through all the stories. I learned a lot of different languages, and I started publishing open source software, free software on SourceForge back in the day. And eventually I went to university for computer science. We can talk more about that experience later. but so I do have some of that classical background as well, and just as like a sort of view on what I think is an important thing I've done in from all this background is the what I call the 3L project, which is basically the reimagining of computing, like looking at where computing could be if we not necessarily ignored everything that we've learned, but didn't require us to be building on it or using the same concepts, but basically saying, "Hey, this is where we have been. Where could we go?" And so with that, I built an OS kernel, an operating system kernel, a programming language. Like I spent a long time designing a programming language that was integrated with the operating system, and for a number of reasons, an interpreter, a compiler, a bootloader, a bunch of tools, um, and and so I have a lot of what I think is a pretty broad range of experience when it comes to programming. I understand a lot of how software works at a lot of different levels, and that's the main reason why I'm bringing that up. And to be clear, I don't even think I'm a super great programmer at this point. I know programmers that are better than me for sure, and I'm always looking to get better as well. So I don't want to take anyone to take this as like me saying I'm great, do what I say. It's more like just my learning is along the way. And I want to end this with sort of the two things that I have decided are most important when it comes to getting better at programming, and that is number one, figuring out what makes a good program. You can't become better at writing programs if you don't even know what the final output should look like. And the second is, of course, figuring out how you get better at producing that ideal output. And so those two things are something I've studied a lot about over the years, read tons of research papers, done a lot of my own research, tried a lot of my own experiments, all in the name of trying to get better and find out what is better. So yeah, that's a real quick, intro on my background, just so you know where I'm coming from when I talk about the rest of this.
Well, thank you for that. I really hope that like we got lucky with my last episode, my story time. We better get into your story time in the next few.
All right, we'll do it. um, yeah, that will be interesting. I have too many stories probably, but I'll try to keep it down. um, yeah, so like I mentioned, there's two main components to becoming good at programming: knowing what is a good program and knowing how to create them yourself. And so the rest of this podcast, we'll be talking about that. Primarily, I'm going to focus a little bit more on knowing how to create good programs. And the reason for that is because I think if you are going through that process, you'll actually also be learning what makes a good program. And I'll explain that a little bit more later. But it's still good to keep that in mind. So now that I have talked a lot, I don't know if you have any thoughts, Austin, on anything I've said so far, or if I should just continue on. But
Well, yeah, because I think we should just continue because it would be nice to hear what your thoughts on what a quote good program is.
mhm.
And what, yeah, how do you know how to create one, like based on the standards of what a good program can be defined as?
Yeah, okay, great. We can start with that. So um, that's a really really hard question to answer in some ways, but
That's why I
also,
asked you.
yeah, I mean, also in some ways, there are some straightforward components to it. It's very clear now that, for example, the more code you write, the more bugs you have. The more bugs you have, the worse your program is. That's a pretty straightforward thing. What is Where it gets more complicated, of course, is you get into the engineering side of like is having more bugs worth it to have more features, or all sorts of things like that. And we're not going to get into that now, other than I think to be able to make those engineering decisions, you need to understand what the ideal state could be. And so, um, yeah, so I'm just saying that to say we're not going to talk about some of that stuff. But what we will talk about is like, in an ideal world, writing an ideal program, what does that look like? You know, number one, an ideal program does like solves the problem and solves it concisely and correctly. You know, like that's not no point in a program if it doesn't do that. You know, and second, you know, no bugs. The ideal program does not have bugs, right? Like you're not gonna. That's just pretty straightforward. But then it gets a little bit less straightforward. Like to me, an ideal program is one with ideal abstractions. And the reason I say that is because the ideal program is one that can be manipulated and extended without causing bugs to come out of nowhere, without a lot of headache. Like you should be able to jump into an ideal program and extend it and have everything continue to work. And so that side of it is a way more difficult thing to quantify. And when we talk about the process, which is a lot of what we'll be talking about besides this, I try to emphasize getting a feel for what that looks like and what that is. And so I think now we'll talk maybe more about like your ideal program or what a good program is maybe later on. But to me, a big part of learning what a good program is the process of getting better at programming in general. And I'll explain what that means in a bit. To start with, and I think this is probably the most important thing that I can ever pass on to anyone that wants to do programming in general, and especially if they want to get better. And that is, you need to find something to build that you really enjoy working on and that is within your capabilities. This is something that a lot of people don't do. What I usually see happen is people have a hard time finding a program that meets them at their level. So, like, I was just working with someone who is learning web development. And so they're learning HTML and CSS, JavaScript, and React all at once, right? And they're like, well, I want to make a program to do XYZ, but it's just, I don't even know where to start. And I'm like, yeah, that makes sense because you don't know any of these technologies well enough. So it's a very intimidating thing. Your brain is like not even processing things really. And so what I always tell people is find just one little bit of programming that you know and get to know it better and write a program in that you enjoy. So in this case, like we just said, okay, let's write a JavaScript program that you can run in the console in your browser. And it takes input via console.input or browser. I forget the API, the browser input, you know, where it pops up something on your screen, you can type in something, you know, and it just does print line or console.log, I guess, in JavaScript. Yeah, so that's like my first thing is like start with something that is simple and that you can do already. And start there. I'm curious what you think, Austin. I see you processing over there.
Well, I mean, what you're saying about like starting with something simple, starting with something in general is huge, especially when you're learning. If
Mm-hmm.
I could go back to, yeah, when I was like 18, just getting into this, instead of like spending a whole lot of time on like reading tutorials and this and that, I really wish that I had decided on a project that I was like, hey, I want to work on this and I want to continue to build this project out. Because if I could go back about 12 years now at this point and I had continued doing that, I can't imagine how much better I would be for it, compared to like a bunch of scattered efforts as well.
Yeah, definitely. I that makes me think of. I'll just mention how it was for me. So I did mention I started with like HTML, and I literally mean HTML. When I was learning, we didn't really use CSS much. It kind of existed, but it wasn't really a thing. JavaScript was like once in a while you'd go on the internet and search for a DHTML button or something. Like it wasn't there wasn't much to learn. I learned HTML and the things I could do in HTML I did. And then when I wanted to do more than that, I actually picked up Visual Basic, which a lot of people laugh at as a language, and I think for a good reason. But the way it worked out for me was I didn't have it's just like one thing. You know, it's not like the web where you have to learn 8 different technologies. So I just learned that and I learned it really well. And I was obsessed with cryptography and security. And so, you know, when I was like, I don't know, in ninth grade or something, I was like writing all these cryptography programs in Visual Basic. And it helped me a lot because I was not necessarily needing to learn. Like, I guess I'll get into my next points here. So, like, when I was learning how to do this, there were times when I came across things I didn't know how to do. And so I had to look them up. But it wasn't so far out of my capabilities that it was hard to get started. I knew how to get started. I was like, oh, I'll just have some way people can put input in here and I'll transform it to output, you know? And maybe this is a way of thinking as well, you know, not trying to get too into the weeds before you start doing anything. But my main point is just that it's important to start where you're at. And then what I did after that is I found a few things that I kept rebuilding. So there's two things. There's the stock market game, which is like this game I made in high school that I played with my family in Visual Basic, right? And it's pretty simple. And what I did after that is anytime I learned a new language, a new library, a new framework, doesn't matter what it was, I implemented the stock market game. I just kept re implementing it because I'm like, oh, I already know exactly what I wanted to do. I don't have to think about that. I can use that as a way to compare it to how I would have done it in a different language or a different library. And of course, along the way, I make it better and better, you know? Like, oh, I'm learning this new technique from this other language. I never thought of it this way. That makes it better in this way, you know? And so I literally still do that now. Like, I think a year ago, I did that in a new thing I was trying. And it happens very quickly. I'm no longer worried about learning that program itself. I'm just worried about learning a new language. Now, if you're just getting started, you know, I would say, you know, that's less important. You're just trying to learn one thing well. And I think it's really important that you just keep doing that. So if it's a fun thing you enjoy doing, so you're not really thinking about like the mechanics so much. You're more thinking about, oh, I really want to make it so that other players can, you know, have this interaction with my player or something. Like when you're thinking at that level, it's a lot more fun. And so the learning comes a lot more naturally.
Yeah, two things that came up um, when you were talking were the first being a lot of people are like they don't know how to get started with making something, and I think that's one of the most critical like skills you can have as a programmer is to figure out how to break down what you're trying to do into like the smallest steps possible, and like getting to like it's very easy to look at this big idea you want to implement and then you're just like staring at it like, oh man, what do I even, what do I do? But just like, okay, hey, you have a splash screen that you want to see, like how do you do that, like really simple, and then you're like, oh, that was easy, okay, what comes next, and then the ball gets rolling there. And then you mentioned about like you have a project that you've been kind of re-implementing and learning new languages with, and this is a funny question that I know I started with when I was after I did like HTML and CSS. I was like, oh, what language should I learn first? And that's like this kind of a pointless question, because once you learn one, you can easily just kind of take that definition, all the definitions, the lexicon of that language, and then you can jump to a new one, and then you see the similarities or perhaps like the enhancements in this new language, and you can just pivot to language to language to language. Um, but I still do recommend JavaScript if anyone's learning a language at first, because you can kind of dip your feet in like client side browser stuff. You can even do backend stuff now with Node. So it helps you get a pretty broad overview of what you can do with a programming language, and then you can always branch out from there. So sorry, that was my
No, that was
kind of
great.
getting away from what you were saying.
No, that was good. I do want to note that like I actually don't recommend JavaScript because like so I compare it to say my Visual Basic experience where it is a very self-contained ecosystem with and you I could easily Google anything and get a working answer. I think and it was easy to do. I opened up Visual Basic Studio or whatever it was called, and I hit the play button, and it runs my program. To debug, I hit the debug button, and I just debug it. Those kinds of things are way, way more difficult in JavaScript world. You have all sorts of different versions, blah, blah, blah. So I don't want to get into that now. I would say what I usually tell people, though, is to start with something you find interesting. And so if it is web, if web is what you want to get into, then I totally agree that JavaScript should be the thing. If you are just wanting to learn programming and you don't care about the web, I would suggest looking for something less complicated because it's definitely a lot more to get into. But I definitely agree with you on all of that. And you even, when you talked about programming languages, you got into, another, we could just talk about it now since you brought it up. And that is programming languages are a sort of like, I think to a lot of people, mystifying topic, right? You're like, I know my language and I don't know all these other languages. And Austin is right. They have similarities. And once you start learning different ones, you'll be able to pick up new ones a lot quicker and be able to move between them a lot quicker. The one thing that I would note is that if you really want to become a good programmer, you need to learn the esoteric ones. So like, definitely Lisp, definitely assembly, definitely APL or K or J or something like that. Small talk, things that are really far out there in terms of like driving programming language features. So that, and the reason why I say it's important is because once you learn, to me, I classify them as like sort of like families or types of languages. You'll eventually learn all of the concepts that are involved in programming languages, and you will be able to jump into new languages super quickly and easily. But even more important, you'll be able to apply techniques from those other languages in whatever language you're working in. So over time, as you learn these languages, you will start picking up on things that are better and not better. Like, I learned Visual Basic and then I was learning Java. And at first it didn't hurt too much, but now that I've learned other things like, say, Lisp, I look at Java as like I don't even want to look at it because I'm like, oh man, it doesn't let me do like anything that I can do in these other languages. But at the same time, if I do need to work in it, I have like these abstract, like potential abstractions and language constructs I've learned from other languages where I'm like, oh, I could actually apply that in Java. And so I end up writing better Java code anyways. So like, even if it's not something I want to do, at least I know a better way of doing it. And so that's my only thing about languages is it's really good to learn a lot of like get a good breadth of languages.
Yeah, what you're saying about like bringing over paradigms from other languages into other ones is it made me think about recently there was a lot of back end work that needed to be done for a feature I was working the front end for, and the back end we're working in is in Ruby on Rails. And I checked out the repo and I started like coding away, and I had a bunch of stuff done, and it looked fine. But the way that I kind of wrote the Ruby in a JavaScript
Mm.
paradigm, and so the first PR, it was good, it was fine, it was functional. But then I met with this guy Rob, who was like, "Well, actually, the way that you should be writing this style of looping or iterating over things in a database is much more effectively done in this way." So it was, even though it was done wrong initially with my like JavaScript esque implementation, it was really good to do it wrong and then be taught how to do that paradigm in Ruby properly. And then I was like, oh wow, like okay. And it made me look at like how it was done in Ruby, and I was like, how can I then maybe bring that knowledge over into how I'm writing my JavaScript as well. So it's really fun bouncing these paradigms back and forth and learning, and then you start coming up with new ideas and more ideas. So yeah,
Yeah, absolutely. That's like one of the best things about learning all these different programming languages. Like, I remember when functional, programming started taking the, web, kind of by storm to a degree. And a lot of people, it was a new thing to them that they had to learn. For me, it was like, oh, I know functional programming from these other things. I already knew it. Or like React with functional reactive programming. It's sort of functional reactive programming. So to me, learning it was very easy. I'm like, oh, it's this concept from this language and this concept from this language, and I'll just okay, I know how to do it now, and I know how it works under the hood, even probably. Like I'm familiar with this stuff. So once you get to that point, you'll be able to really start picking it up. But I did want to latch on to another thing you said, which was um, you had somebody who is good at programming help you get better. And that is also something that, is maybe more difficult to do if you're, sort of a shy programmer. But I found that finding at least one or two friends that really want to get good at programming or that already are good at programming and program with them helps a ton. So like I have a friend that I met in college who I consider to be one of the best programmers, and we spent many nights in college staying up till 6 a.m. writing code together. Like we had projects together, and I learned a lot there. And I also hung out on, I know this dates me, but I hung out on IRC a lot. And so I hung out with a lot of older
what's that?
programmers. Yeah, thanks. Yeah, I hung out with a lot of very older, not very older, very experienced older programmers. Um, and that also helped a lot, just to see their attitude on how they approach things and learn from them. So that's something that I would recommend trying to do.
Yeah, even if you are shy, it's completely worth it to find a mentor in like as quickly as you can. Like this isn't related to programming, but it's kind of the same. Like if you go to the gym and you're doing bench press and you get to like a certain weight where you're doing 8 repetitions at this weight, and if you were to try to increase the weight, there's a good chance that the bar will fall on you and you're not going to be able to progress because it's just too heavy for you. And that's the time you get over being shy and you walk up to the big jack dude across the gym and you're like, hey man, could you spot me and make sure this weight doesn't crush me when I try to push it up? And then like I you do that, this guy helps you, and then like within a week you're already lifting more than you had the week prior, and you've overcome a plateau. So the same thing with programming, like reach out to someone that you know is better than you and ask them for help. I wouldn't be where I am without like my previous mentor Raphael, and now honestly you've helped me a ton. So yeah, you have to get over being shy. It's not helping you at all.
Yeah, well, thank you. I like to, if you can't tell, I like to help people get better. So uh, I appreciate that. Yeah, I actually, so what I was really maybe saying is not even necessarily a mentor. That would be great. I don't know if I ever actually really had that, to be honest. I did find a friend that was so when I was younger, I had a friend who I don't think was the best programmer, but they liked programming, and so that was nice to move forward. But later, I did find a friend who, yeah, they're maybe better than me, but we were mostly learning together. And I think they, I guess what set them apart was they also really wanted to become a better programmer. And so when they were approaching problems, they were not afraid to dig in and try to really understand what was going. And that was like something that I really identified with me. Was like, yeah, I want to do that too. I want to understand what's going on. And so there's like, I guess that's really what I'm saying is you can have like somebody that does programming. And I know I always throw Java in this, but that maybe they do Java programming and that's what they do, and they're happy not really doing much else. What I'm saying is whether it's a mentor or just a friend, somebody that will challenge you and push you to get better, as well as them trying to get better. Um, and I think that ties again into another thing that I wanted to mention, and I just mentioned, I guess, which is um, it's really, really important. I think one of the most important things out of everything I'm saying is not to be intimidated by the unknown. This is such a common and for me frustrating thing that I run into is when a programmer, especially if there's a bug um, or something they don't understand, a bug, a concept, they often don't try to fully understand it. They will just sort of try to make their program work, fiddle with it, try to make it work, and then move on. So nothing wrong with fiddling with it and trying to make it work, but if you want to be a good programmer, those are the situations where you need to go, all right, I'm going to like, I know it's going to be hard and I'm probably going to get into stuff I don't understand, but I am going to figure it out. And I think that is a quality that sets apart someone that is just trying to be a programmer from someone who's trying to become a really good programmer. Is you cannot be afraid of the unknown. And so, like, as an example for me, I've one of the reasons I run Linux on my systems is because of that exact thing. I do not want to be unable to understand what's going on. So if I run into something in my system and I don't like what it's doing, or in the reverse case, I've done this as well. I like what it's doing. I will open up the source code and I'm like, I don't know nothing. I might even not have even known C at the time or something, but I'm like, I'm just gonna figure this out. And I think that is a really important quality in anyone that wants to get really good at programming. You have to, like we said, start with stuff that you know, but you also have to be willing and happy at some point to dive into the unknown.
Yeah, I can't tell you how many times. Well, I so there's this book, a short book I read called The Flinch, where they did studies on MMA fighters, where they were like watching the final match where the fight was decided, who was the victor, who was the loser, and there was this. both fighters had this reaction where they flinched at this like critical moment of the fight. And the losing fighter, they flinched backwards when the other fighter that won flinched forward into the attack. They landed the attack, they won the fight. And it's kind of the same with anything in life. And I'll talk about it with programming. You run into this error, and your immediate reaction is this like oh, and you see it pops up, and you can get frantic or upset and like wondering like, oh, what do I do? Go look on Google, blah blah blah, just try to find something on Stack Overflow, or be like, okay, well, let me read this. What's like really going on, and look at it as an opportunity to get better. I know I'm not perfect at this, and you help me a lot by pointing out these things, and you ask me these really annoying questions that make me have to look at the uncomfortable things that do lead to growing. And that was what you kind of touched on earlier, where it's like you can't get intimidated by the unknown. Like you're going to, especially with programming, where you're literally having to take problems and figure out and create brand new solutions to problems every day. You're going to be facing the unknown in mass quantity. So it's really important to adopt this mindset of like, okay, if I conquer this problem, I'm literally growing my toolkit, my repository of knowledge on how to solve problems, not just even on the computer within programming, but it like there's so much spillover from doing programming into life that you can start breaking down just about any problem you encounter and use the same paradigms for like breaking it down and then figuring out how to move forward.
Yeah, definitely. I think like this oftentimes reminds me of the friend that I talked about that I met in college. When we were writing a media player together, and we used a library for part of it. And whenever we ran into behavior we didn't expect, I think before I'd met this friend, my natural instinct was just to do the fiddle with it and just try to find a way to make it work and then move on. But what my friend always did, no matter what, was, all right, let's look at the documentation. And we would read through the documentation first and be like, okay, what does the documentation say? Does it say it should behave this way? If it does, then okay, now we understand. If it doesn't, let's look at the code. What is the code doing, of the library we're using? Let's figure it out. And the end result of that was like Austin said, you learn a lot more about all these other systems, and then B, your own system will work better and function better because you actually understand what you're doing. And so I think that's really important. I think I just want to get into a few other points that are, I think, also important to my at least experience, and that is, I spent a lot of time reading other people's code. So, whether it's people that are like supposedly good at programming or just random people's code, I would find open source code and I would read it and I would look at it and and try to understand, okay, why did they do it this way? Is this a good way to do it? Just sort of analyzing it. But then what I did after that was I tried to experiment with programs in a way that you might find very weird and surprising. I would take code and try to make it into sort of other things. Like I would make it into a poem. I'd be like, can I write a program that is also a poem? Or can I write a program that looks like a cat? Or can I make how short can I make this program? Is there like, what kind of techniques can I do to make it short? Or I would do the opposite. Let me just make this program as long and unwieldy as I possibly can. So I literally did this. I would sit there and just write all these different things. And it was really eye opening to me because it sort of stretched my way of thinking about programs as this sort of rote thing that you just always redo the same thing into this creative thing where I'm now seeing programs as a malleable creative expression. And through that, I've learned a lot about actually what makes it sounds weird, but I learned a lot about what makes a program good because I would write these and be like, oh, this is a good program, even though it's like a poem. How can that be, you know? And so it helped me like, oh, so actually it's not necessarily that it's like a poem that's making it good. It's that the poem forced me to write it in a certain way that forced me to use abstractions in a certain way. So it helped me discover things like that.
Yeah, that's really cool. It makes me wonder how I like writing haikus, especially when I'm processing some emotions, especially with women in the past. I've written quite a few haikus, and it makes me wonder how I could do the 575 syllables, or I don't even know the word right now, per line on a program. I'm not really sure how that would work. But yeah, I like the idea of the practice to be like, okay, how am I? Yeah, that's really cool. That's creative, man.
Thanks.
That's your secret, I see.
Yeah.
Mm.
Well, there's even if you're really into it, I think there's even a name for it, I think, where like your code looks like the output and there's all sorts of like competitions around things like this, like shortest program to do XYZ or whatever. There's like lots of stuff you could get into. And I think it's actually really valuable to learn about the possibilities of your program. uh,
Yeah, I've never really done those like code challenges, but the other day I some company wanted to interview with me and they kept pushing me to interview and I was like, okay, fine. And we did like a how to print out like taking any number input and putting it into like a string output. So if you put in the number 10, it would write 10. And if you put in like 5,000, it would have to like know how to write out FIVE 1000, right? And it was quite interesting looking at like how you could do it one way, or how you could do the modulus to determine other things to print out, and then like looking at it like, okay, how can I take this and figure out how to do it in less lines. It was a good exercise, and it's made me look at these code challenges a little bit more recently, and it's been fun for playing with my brain.
yeah. I haven't officially been in any code competition things since I think high school, but I do like doing the challenges myself. Yeah, so um, the thing that I guess to sort of summarize a lot of what we've been talking about so far is I, there's a lot of different techniques, a lot of things you can learn, but the most important thing is to remember that when you're doing this, you're looking at what makes a better program. So whether it's when you're writing your program as a poem or whether you're, working on something with a friend or whatever it is, like you're analyzing the program and being like, oh, I wrote it this way. Is there a better way that I could write it? Or um, this way that I wrote it seems to naturally not have as many bugs. These are the kinds of things that I think you will learn as you go through this process. So, like, I know I haven't talked a lot about like what Austin brought up at the beginning, which is what actually makes a program good. And the reason for that is because I think the best way to learn it is to there's obviously some things we can tell you now, like we did earlier about bugs and stuff, but a large part of it for me has been just experimenting, seeing other code, looking at other code, and always saying, is there a way I could make it better? Or is this better than the way I would have done it? And then you'll start to sort of see patterns of like what actually made it better. What about this way of abstracting code made it better than maybe version 1? Like that's something you could do. Look at the evolution of a program and see if it got better or worse. If it got better, what made it get better? That's always what I'm doing. And so to me, I would say what makes a program good, part of that is this process. If you do this process, I guarantee you will start to see patterns, and you will start to see things that you think makes programs better. Like I learned with Visual Basic in a very imperative style of programming. And then I learned languages that were purely functional. Then I learned other, languages with other paradigms, And now in my head, I'm like, oh, okay, in this situation, this paradigm seems to work the best. And I know that because I have this experience of trying out different paradigms, different languages in different situations, So like, by itself, I don't have like a perfect answer for what makes a program good. I could talk more about it. There's certainly more we could discuss, but I think the important part in this podcast and the thing I'm trying to convey here is the process. Like go through this process with an eye for what makes it better, and you'll learn over time what actually makes it better. Yeah, go ahead, Austin.
Well, I know that it's in the show notes later, this whole bottoms up approach of like, hey, just take your idea. Don't worry about too much about how it's written. Just like get it written and then take a step back and look at what you've written and analyze it, discover what things you could improve, and then keep tinkering with it and using what you've written as the playground to continue to learn how to make it better. And it's been really important in the last like few months as I've been building a lot of my own software, just like, hey, getting something done, not prematurely optimizing anything. And then as new use cases, learnings, paradigms, etc. come in, this thing continues to evolve. And I'm like, wow, it's a really cool creative process.
Yeah, definitely. I think that you bring up a good point. When you go through this process, you will start learning all these different ways of writing programs, and you will learn which ones you think work better. Like I agree, I like bottom up programming. I learned that when I was learning about Lisp, like that's I think like you can definitely get by without doing it, but you'll be a lot happier if you go through this experience and see all the different possibilities. So the next thing that I wanted to talk about is more of like just things that aren't maybe as much a part of the process, so much as things that I would recommend you do in terms of just making you more efficient as a programmer. And the first one of those is learn how a program actually gets run on hardware. So like whether that means writing assembly code or whether that means writing code in some other language and seeing what that gets compiled to, like understanding how the hardware works is very, very valuable in understanding why a lot of the software is written the way that it is. Especially everything we do ultimately needs to perform well enough, and performance is 100% tied to the hardware you're running on. And so if you want to be able to be good at that aspect of things, it really helps to understand your hardware and understand how it runs on the hardware. Now, I'm not a hardware expert. I understand, in college, I guess we did build CPUs, technically, like diagrammed them. And so I understand how, x86 CPUs work. But what I'm really talking about is like, a little bit higher, like right above that, the code that actually gets run on the hardware, how that interacts with like the TLB, all these different systems that are in our computers. It's not a maybe requirement to be a really good programmer, but I found it really helps me a lot because I can look at something a lot higher level, and if I know how things get compiled or whatever, I can make better choices in what I do. And that ties into the next thing, which is data structures and algorithms. Um, I, this is a thing that you'll learn in college, and it's, a big emphasis there, and also at, certain well known corporations when they interview you. But I personally don't consider it to be necessarily that important for being a good programmer, because a good programmer can figure this stuff out as they go if they need to. But you will become a more efficient programmer if you are familiar with all the common data structures and algorithms, because you will be able to make better engineering decisions in terms of when to use them and that kind of thing. Yeah, so I don't know, Austin, if you've learned a lot about data structures and algorithms, but
Yeah, honestly, it's something I would say is a weak area of mine, especially like structuring data. It's quite a scary thing, because when you think about, if you do it wrong and things begin scaling up like rapidly, and you've organized things improperly, like, just that gives me nightmares thinking about like the potential messes you can have just from making a small bad decision up front. So yeah, if you have any further advice on this in a short way that you could touch upon, like some basics of like what to think about as you're organizing things, that would be cool.
my advice would probably be to start with just get a quick understanding of the possibilities. So you can look up resources on the common data structures and algorithms and just get a high level overview of like, oh, this data structure is used for this or is made up of like this thing or whatever. Like, and then using the rest of this process to dive into it and say, oh, when you do that, you'll be like, oh, hey, maybe actually I should have used this data structure for this use case. Go implement it and see how it goes. That would be my recommended way of learning it. Some people learn best just getting a book and reading through all of them, which is also, if that's how you learn, then you can do that too. It's not really my style, but yeah. So that would be my recommendation. It does also like sort of tie into something that I guess we could have a whole nother episode on, which is, we talked about bottom up programming, but the other sort of fundamental when it comes to me figuring out where to start is the data. So you'll notice whenever I'm talking to users, or the back end or whoever it is, the thing that I always focus on first is the data. Where does the data come from? What do you do with the data? And then I look at my program and I look at, okay, what is the best way to store that data and utilize that data? Because once you get that right, the rest of your program will just naturally work a lot better. So that would be my recommendation on that. And I think we're getting close to having to wind things up here. But I did want to touch a little bit on more concrete things, like when it comes to React. So we've talked a lot about really general purpose things, things that I have found helped me get better as a programmer. But I thought it would be useful real quick to just run through some ideas I had on things that you could do right now that I think would start help making you a better programmer in a small way, and maybe in a large way, depending on where you take it. And that is, you could experiment with different ways of writing components, different ways of passing state around, different ways of outputting things, maybe embedding components within components. Just mess around with it, see what you can come up with. And that ties into like another thing was different methods of composition. you can make a big component that covers a lot of things, or you can make that big component, be broken down into smaller components, or you can start with a bottom up approach and try to, you know, create a system where your components compose with each other. There's like a lot of different options. So what I will do is, like in my stock market game React that I made, I play with these things. I've played with different ways of doing components. And so that's something that I found useful, and you may as well. And related to that would be hooks. You can look at different ways of breaking up hooks. And I think especially building hooks and composing hooks together, like hooks as a sort of abstraction. Another option is you could try to make your code read more like a story. I talked about a poem earlier. You could write some React code and make it be like a story. So you're reading the code and it feels like you're reading a story or a book. Or again, like I mentioned before, try to make your code as short as possible. Not something that maybe you would, put in a PR for your employer, but like just try to like do anything you can possibly think of to make your React code really short. Or anything along these lines, like just ways to sort of stretch your React thinking. Do you have any other ideas, Austin, or you just want to do all those right now?
Yeah, all of them. Yeah, one of my favorite things in React is like making a function and making it pretty big, fat, and verbose, and then you can look at it and begin with like the Babel transpilers. You can look at how to like shorten up what you've written, and then you just make this like hyper condensed little teeny function that does so much, but then you can't even read it. It's like, what does this thing even do? But it's pretty cool what you can turn into these things, like just like using the reducers and the spread operators on arrays and all these little utilities that you have with Babel. um, they're really fun, but yeah, they don't make it very readable in the end. So yeah, I personally write some pretty ugly old, like using just big meaty if blocks and stuff, and it's like, there's probably a better way to do it, but here you can really easily tell what's going on. Um, yeah, all of the things you touched on just now are really cool, and there's so many options to explore, and that's the point. Like you said, figure out something that makes you excited, do it that way, and then yeah, maybe have a friend or a mentor that you can share it with and bounce things off of, so that you can kind of get a second set of eyes, outside looking in perspective, and maybe you get some more ideas, or you learn how to improve it further.
Yeah, yeah, absolutely. That was a great summary. Thanks, Austin. Totally, yeah, totally agree. And I just wanted to say, sort of in closing, this is something that I really enjoy working with people on. So if you have questions about this, on a more personal level, or you just want some feedback, you can actually email me directly at owlcreek.studio. So that's th@owlcreek.studio. I can't promise I will, be able to tutor you for 8 hours a day or anything, but like anything I can do to help, I love working on this kind of thing. And as always, if you have feedback or questions about the podcast in general, that would be an email to the React Show at owlcreek.studio. It's been great having you again, Austin. I've really enjoyed going through this. I hope it's been useful to you all. Yeah, so did you have anything else, Austin, or is it time to sign off here?
Yeah, one more plug, shameless plug on, if you go to owlcreek.studio, you can look at the email sign up section we have, and there's a book that Thomas wrote on the foundations of React where you kind of build out your own version of it. And I think it really ties into this episode of how you said, like, go look at how things are running on the hardware. and perhaps this in a hardware level implementation, but you can kind of get an idea of like, oh, this is how React kind of works under the hood, and may give you some inspiration about how you write in React or in other languages. So that book, that's free right now for a limited time when you sign up for the email. So get it while it's hot before we jack the price up to probably a couple thousand, because it's like it's that quality, you know. And otherwise, yeah, thanks for coming out and listening to us. We're over like 750 downloads on our episodes. Spotify has overtaken the other one. I forget the cast something, but thanks to all the listeners out there. And my voice sounds really like helium coming through. Not anymore. It was weird. There was like some audio distortion where my voice sounded like I was on helium. So maybe you'll pick that up too. Y'all have a good day. Thank you.
Yeah, thank you. And thank you, Austin, for the plug on the book. You're absolutely right. I didn't think of that. But if you want to know how React works internally, it's probably a good way to do that. Yeah, so thank you. And thank you all for joining us. Yeah, we'll be back next week.